Hi, this is Holly Becker. For this project, our group focused on the concept of coding, specifically on Texas Instruments' 10 Minutes of Code. But before we jump into 10 Minutes of Code, it's important to know why coding is important in today's classrooms. The following slides provide 10 reasons given by the real experts why our kids need to learn how to code. Number 1, coding teaches you how to think. I think everybody in this country should learn how to program a computer because it teaches you how to think. Number 2, our world needs talented coders. Our policy at Facebook is literally to hire as many talented engineers as we can find. There just aren't enough people who are trained and have these skills today. Coding can help you achieve your dreams. If you can program a computer, you can achieve your dreams. A computer doesn't care about your family background, your gender, just that you know how to code. Number 4, coding is the new literacy. Code has become the 4th literacy. Everyone needs to know how our digital world works, not just engineers. Coding prepares you for the future. To prepare humanity for the next 100 years, we need more of our children to learn computer programming skills, regardless of their profession. Along with reading and writing, the ability to program and code is going to define what an educated person is. Number 6, feel empowered. Gain confidence. Learning to code makes kids feel empowered, creative, and confident. If we want our youngsters to retain these traits into adulthood, a great option is to expose them to computer programming in their youth. Number 7, we all depend on technology. We all depend on technology to communicate, to bank, and none of us know how to read and write code. It is important for these kids right now, starting at 8 years old, to read and write code. Unlock creativity and open doors. Every student deserves the opportunity to learn computer programming. Coding can unlock creativity and open doors for an entire generation of American students. We need more coders, not just in the tech industry, but in every industry. Coding is a 21st century skill all of the kids today will need, along with reading, writing, and arithmetic, a basic understanding of computation and the role that it plays across a wide range of disciplines. Coding is engaging and empowering. It's a 21st century skill. And number 10, coding gives you superpowers. I believe technology should give us superpowers. Everyone should have the opportunity to learn to think, analyze, and create with technology. Now that we know how important coding really is, let's get into our classrooms and let's get coding.
Right, today we are going to be looking at how to program on the TI-83 Plus family of calculators. We will look at how to program a Pythagorean theorem type code. I'm going to be using this TI-84 Plus Silver Edition on screen here. I downloaded it at WebItEmu, just a simple emulator that you can use for Windows, Mac, or Android. I do have this on my cell phone. First, I'm going to begin by showing you just how to use the program or programs and the things that we're going to be using. So you will begin by clicking Program. Here you will see Execute, Edit, or New. You'll see I already have the program made. We will come back and edit it later, but for now I'm just going to show you Create New. Here's where you type in the name of your program. I'm just going to call this one Program E, for example. Once you are in Program E, you are now creating your program. You are beginning to code. So we will click this Program button to see all of our options. CTL is all of our control codes. I/O is all of our input-output commands. And this one just executes one program inside of another. So we won't be using this. We will focus on these two. In the control list, we will mainly focus today on, we will use pause, we will use label. Let's see what else. And we will create a menu. As well at the bottom here, we will stop the program at different points. From our input-output list, we will prompt. This one will basically let you input some values. We will display. This will just display text on the screen. We will use output. This allows you to display text over some other text. So after we've displayed something, we will output something on top of it. We will clear home. So again, this clears every text that's on the screen and just comes back to the home spot. And let's see what else. Oh, I think that was it for our input-output screen. So those are all of the things that we'll be using in our program. I'm actually going to quit, go back to the program screen. I'm just going to show you under Edit the program for the Pythagorean theorem. Now again, I do have everything over here. So again, you can just kind of read and follow along here. You saw how I started the program. This would be, again, just how to name the program. I named my last one E. You can name this one Pythagore. To create a menu, like we did here, again, we go to the program and drop down. I would type all of this in here. It looks like I have looking. I need it to say looking for, so 2 O's. There we go. Then from there, it runs through the whole menu process. After we have created a menu, then we would start a label A. So after you choose this hypotenuse, it would go to label A. This is label A. It would display, and we went over how to display something. We would want it to display the actual Pythagorean theorem formula. Next, we would prompt values A and B. So these values, although this is just text, these are the actual variables. Once we know what variables A and B are, we'll have it run a formula. So we need to type in this actual formula. This one up here, square root A squared plus B squared, will be stored as C. Notice this is not an equal sign. This is the arrow key found right here. Same thing, A squared plus B squared is stored as the variable D. Then we will clear home so that it clears everything on screen and begins at the top. We'll have it display again, and we'll say hypotenuse is, comma, a blank line, comma, C, comma, a blank line, comma, oops, and I will need a quotation here, or with the square root. Now that it is displaying all of the answers there, I guess C is the only answer, we also want it to output 5th line, 5th spot, D. So, as long as everything is typed in correctly like this, this D will overlay right here, right behind that square root spot. Now that it's displayed all of the answers, we'll have it pause and wait for the user to click enter before going to stop. That will end our program. So that'll end everything on label A. Next we will go to label B, which essentially we type in everything the exact same. The only difference is, again, here is that formula. Now we are putting in B and C. C squared minus B squared. Square root of all of that gets stored as A, or C squared minus B squared gets stored as Z. And then, of course, we clear home again. The reason we do it that way is because this time we're looking for the leg. So the leg is then a blank screen, or a blank line, then output A, blank line, or square root of, output 5th line, 5th spot, Z, pause, and stop. So again, this will run the program if we are looking for a leg versus finding the hypotenuse. Now that we have the program created, I'm going to quit out of that, go to Program List again, run down to Pythagore, and run the actual program. This will make sure that we can check everything and make sure everything works correctly. So if I run it looking for the hypotenuse and say that A is 3 and B is 4, it'll run the program and say that hypotenuse is 5, or the square root of 25. So it must follow then that our hypotenuse formula works out correctly. We're going to run this program again, this time choosing the leg. Now it didn't clear before, that's why these are at the bottom. That's fine. We will say that B value is 7, C value is 10. So again, it works correctly. It runs it for us. It gives us an output of an irrational number that only goes so many decimal places, or it just says that's the square root of 51. So we can see both in the radical form or kind of a rounded decimal form as well. So this program does seem to work for us. That would be how to program everything on there. If you want to see a full step-by-step video of this program, it's about 15 minutes long. Please head to this site. Thank you for watching.
Hi, I'd like to start talking to you about the next piece after you learn to program on the 84. You could also learn to program on the Inspire. Rather than go through a similar thing about programming, because a lot of the coding is the same, I'm just going to tell you a couple of quick things. The Inspire's got a couple of main differences. When you finish typing your code, you have to save your syntax. And sometimes when you have the commands, you don't have to go looking for the commands. You actually type them like with a capital letter and then lower cases. Other than that, most of the programming stuff that Jared just showed you is very similar on the Inspire. An additional piece that I wanted to show you was on the TI website. Up here, you'll see it's education.ti.com. And if you go to the TI website, under activities, you can go to TI codes, and they're going to take you through the 10 minutes of code, which was a big part of our other handout we did last week. And you can do it for the 84 or for the Inspire or for the Innovator Hub, which also now includes the Rover, which is a little kind of a car-like thing that you can hook up to your calculator and make it do things. So here is the Inspire screen. And when you go to each of these things, they have it all very designed in the theme of 10 minutes of code. So here you can again choose a second time either the Inspire or the Innovator or just the Teacher's Lounge, but I'm going to choose specifically the Inspire. And when you're in the Inspire, you're going to get several things. All of them are the same. The 84 is the same thing. The Texas Instruments has organized several units, 1, 2, 3, 4, and 5 that are 10 minutes of code that are set up to help you learn with your students or teach your students, or you could assign it as extra homework. They can work on their side. Every one of them has a Skill Builder 1, a Skill Builder 2, a Skill Builder 3, and an application. So you learn something, you learn the next layer, you learn the next layer, and then you have to actually create something that does it. It goes through it in a very step-by-step form. And as well, there are teacher notes. So if you click on the teacher's notes, you can see, hang on, I think I have one pulled up. Yep, here's one that looks like when it's pulled up. So you can actually see the different parts that it goes through, training for the teacher, what are the extra pieces of information you'd need. So this 10 minutes of code site that's available is very helpful in learning to do all of this programming, and we would encourage you to consider doing it. The one thing that we also consider really helpful is we like to do the coding for math, since we're doing this in math classes, not as a separate class.